G'day viewers, and Gary back here again. This is my rebuttal, round 2, episode 2, whatever you want to call it. No infinite cotton candy machine for you, Gary. I'm going to talk about pulsars, magnetars and black holes. And we're going to apply some numbers, some real numbers, and we're going to go over a few points of contention that we have. And obviously there are no field lines in space. They were drawn to show the interaction between the gravitons and the mass. That's all. And my argument is that all these forces interact at 90 degrees. There's so many examples in real life. My second point of contention is I'll say that generally light will travel faster than neutrinos, except through matter where neutrinos win the race. I'm not saying anything's travelling faster than light at this point. Okay, so just get that concrete in your head. Neutrinos will win the race through a bunch of mountains or mass or whatever. They have done the experiment. It was through the Italian Alps from memory. Okay. Magnets. If you rotate the magnets 90 degrees from what they are, your generator won't work. Your magnetic circuit won't be inducing a voltage in the windings. So, right. Point of contention number 4. Your straight line theory works in most but not all instances. And they've proven black holes exist. There's no doubt about that. I had that set in my head, and I'll actually argue the physics of black holes with physicists because I believe they have it wrong. They keep quoting infinity. You know, everyone makes mistakes, and I will admit that I made a mistake in my description of the 3 particles I described as massless particles. And it appears that you still don't understand the concept of a massless particle. Right, let's get back to pulsars. You claim they're just binary objects. Only very few pulsars are binary objects. Mainly they're single neutron stars, and they rotate at various angular velocities, and they do follow the laws of the conservation of momentum and conservation of angular momentum. That is, as they are shrinking, their rotational velocity increases. So, and as I said about magnons, that's what I called the magnetic particles in a magnetic field. Obviously my theory is not complete yet, but it's more complete than anyone else has. In a pulsar, they actually accelerated like a linear accelerator, and some of the particles escape. They absorb that much energy in their acceleration that they are accelerated into X-rays and gamma rays. Now, the more powerful a pulsar, the smaller its radius and it has a proportional increase in density. This is borne out by the study of many pulsars, and we can extrapolate from the current data set, and I will tell you right now that once the Schwarzschild radius increases above the radius of the star, that's when you get your black hole. So that's as soon as the event horizon is above the physical boundary of the planet, it won't let light escape. And I've watched plenty of videos and I've studied this for years, and you know, you really got to study it and understand it, and you watch the tensor equations and they'll start saying, oh, you put infinity in here, and this is my point of contention with conventional physics, is you cannot use the term infinity. You can approach infinity, but even if you put every particle in our known observable universe, it's still nowhere near infinity. I've worked with numbers up to, I think it was 1.62 times 10 to the 1018th power, and the degree of certainty for the answer was something like 1.62 times 10 to the 120th power. That's a huge error factor, huge. So once you get to those super huge numbers, you just have to stop and say, no, enough's enough, that's out of bounds. The error factor is just too big. But getting back to what you call these ant pincers. Now you could dig these up in your backyard and get a paleontologist out, and you get two paleontologists. One guy will tell you, oh, that's a dinosaur tooth and it belonged to a dinosaur that lived here 67.3 million years ago, and it had feathers and this and that, and they'll make the complete wrong conclusion based on the tiniest piece of evidence. Okay? The other guy will come along and he'll go, no, that's a modern tooth, it looks like a whale tooth, which it is. They're sperm whale teeth. So we'll keep them. They're my little, they're my devil's horns, to speak. Okay, so we'll get back to pulsars. You know, pulsars are around 25 kilometres in diameter and weighs a little bit more than our sun, which is about 2 times 10 to the 27th power in kilograms, a very big number. Billions of billions of billions of tonnes. Pulsars roughly 1.2 to 2 point something. The size doesn't matter. It's an evolution of a star. It's the result of a supernova. That's your neutron star, and they only become pulsars when they've got enough spin factor and enough energy to accelerate the magnons internally to relativistic velocities, the speed of light, and they actually try and accelerate them faster, but you can't exceed the speed of light. So that is like it's like a braking force, and that's converted into energy frequency of the particles. So you're converting magnons into photons. The next stage up from a pulsar is a magnetar. That's a pretty wild jump up in magnitude, many hundreds to thousands of times in mass, but here's the weird thing, is they're smaller. A magnetar is around 15 kilometres in diameter, and this leads me to the postulation that black holes, the actual physical black hole, is way smaller than 15 kilometres in diameter, and the inference is that the bigger the black hole, the more mass the black hole has, the smaller it is. And the smaller it is, the more intense the gravitational field. And I hate to say it, but this is drawing me into temporal distortion, time dilation. I can see on the internet, I can go there now and you can see it. You can see pictures, actual pictures of gravitational lensing, and this is not bent space. The photon is trying to travel in a straight line, but it can't always do that because the actual space is getting pulled into the black hole. It's like, you reckon I talk about mermaids, so I've got this mermaid, I've told her to swim across a lake. She swims in a straight line, perfect straight line. So we'll take this photon mermaid and we'll put her in a river and we'll say, swim in a straight line. Now in the centre of the river, the current is moving faster than it is on the outside, closer to the shore. So she starts off in a straight line. As she's swimming across, the current is getting stronger. Her actual path through the river, she's going in a straight line, but the space she's swimming in is moving. So it doesn't violate anything that you say. She's swimming in a straight line. As far as she's concerned, she's swimming in a straight line. She gets to the other side of the river and she's downstream. But it doesn't matter how far, but anyway. The flowing of the river has caused the bending of her trajectory. So that's the explanation for gravitational lensing. It's the photon isn't moving, the medium at which it's moving through is moving. So from now on, I don't want you to say the speed of force. I'd like you to acknowledge the speed of light, which is the same speed as gravity and the same speed as magnetism. And my argument is that the energy particles within the gravity field and within a magnetic field do not have enough energy to be light and escape their confines. So I think I've presented enough evidence. You can go on the internet and Google neutrino experiments, or you could Google Schwarzschild radius, and you'll see the basic mistake that they're making. They're assuming infinity. And my thoughts on the matter of black holes is if we put every particle in the universe, observable universe, into a giant black hole, it would collapse to the point where it would be emitted as energy. The gravity itself would break and then be reborn as a new universe, or a new part of this universe. There's trillions of stars in our universe, and there is more than one supernova every day. The point is, we cannot detect them. We detect a few, sometimes if they're close to Earth, like the Crab Nebula in 1054, which was observed by the Chinese and written as the birth of a new star. I'd like you to study a bit of astrophysics, and that might shape your view of physics. And in my experience and education, you can never ever achieve infinity. You can approach infinity, but you can't achieve it. Okay. Now, of course, gravity is under the rule of the inverse square law, and the distance obviously dictates the strength of the field. Now, obviously, the mass of the body that you're measuring, the gravity also. So we'll move along. And I named 3 objects which I believe to be manifestations of the same thing, and I'll offer some proof. Point of contention number 7, Tesla. He actually invented your and, or, not, nor, and exclusive or logic gates. Every gate that makes up your computer was patented by Nikola Tesla. So, and he also invented the 3-phase polyphase motor based on rotating magnetic field geometry. So he was a genius engineer, a bit different from Einstein, who was a genius theoretician. Right, so 2 different guys, 2 different fields of expertise, and both contributed greatly to our modern day physics. So I've already said it, but I've written it down here. Contention number 8, no faster than light speed. And I say light speed, you cannot just generically use the speed of force, because there are forces that travel slower, way slower than light. So to call something the speed of force is, that's your little pet naming convention, and it's wrong. It's just, so stick to the speed of light. A bit of paper here. And I speak English, but you don't seem to understand English, perhaps. Maybe I should speak American. And in the previous video I said proton when I meant to say photon. A little more. I don't like the fact I'm getting drawn into this temporal distortion, but it appears to be the logical answer. And as they say, truth is stranger than fiction. Anyway, Gary, that's about it. You can see if you can argue against that, and we'll talk to you later. Cheers.